So now we're going to take a look at a parabola, and we're going to go through the entire process, and that includes graphing and identifying all of the key parts. So for graphing, we're going to start with our parent table, which is -2, -1, 0, 1, and 2, 4, 1, 0, 1, and 4. Because really, this is just some version of an x squared equation. Now, I notice that my a is 2, so that's going to multiply or stretch all of my y's. So my x's are going to remain the same, but my y's are all going to be doubled. I notice my c is -3, my d is -4, so that's going to take all of my x's and add 3 to them. It's going to take all of my y's and subtract 4 from them. So my x's are going to turn into 1, 2, 3, 4, 5. And remember that even though my c is -3, I'm still going to add 3, because I'm going to do the opposite with either of the transformation numbers that are in the parentheses. And by opposite, I mean the opposite sign, or opposite operation. The y's I'm going to subtract 4, so it becomes 4, -2, -4, -2, and 4. So now let's make a graph. So 1, 4, 2, -2, 3, -4, 4, -2, and 5, 4. And there's my parabola. Now, what are the important aspects of that parabola that we ask to identify? Well, we always ask for the vertex. Vertex is very easy to identify. It's the most important point of the parabola. It is the middle point of the parabola, some people would describe it. So it's 3, -4. Usually we ask if it's concave up or down. Since this is opening up, we would say it's concave up. And we ask if that vertex is a minimum or a maximum point. In this case, since it's at the lowest, it would be a minimum point. We typically ask for the domain, and for quadratics, the domain is always going to be all real numbers, because the u is going to extend in to the left and to the right infinitely in either direction. The range is not going to be all real numbers because it doesn't extend up and down forever. Instead, it starts at -4 and goes everywhere above it. So I can just write y is greater than or equal to -4. Last but not least is identifying my axis of symmetry. My axis of symmetry, pretty sure I spelled that wrong, is the equation of the line that cuts the parabola in half. Well, that's always going to be a vertical line, so it's going to be x equals, and it's going to pass through the vertex, so the x value is going to match up with the x value from the vertex, so x equals 3. Now last but not least, I'm going to have to find my y-intercept and my x-intercepts. Well, to find my y-intercept, I always need to remember that I'm going to plug in 0 for x. Always. So 2 times 0 minus 3 squared minus 4 is 2 times -3 squared minus 4, 2 times 9 minus 4, 18 minus 4, 14. So my y-intercept is at 0, 14. Now for my x-intercepts, I'm going to do the opposite. Now I'm going to make y equal 0. And by looking at my graph, remember that my x-intercepts are the places where the graph crosses the x-axis. I can see that there are going to be 2 of them. So that's a good visual check. So 0 equals 2 times x minus 3 squared minus 4. And now I'm just going to solve this equation like I normally would using my radicals. So I'll add 4, 2 times x minus 3 squared. I'll divide by 2. So 2 equals x minus 3 squared. I'll take the square root, plus or minus in front of that radical, So I have plus or minus radical 2 equals x minus 3. And now I'll have to add 3. So 3 plus or minus radical 2 is equal to x. Now I'm just going to go to my calculator. Just going to plug in there 3 plus radical 2, which gives me 4.41, and 3 minus radical 2, which gives me 1.59. Looking back at the 2 points, it looks like those are correct.